Vertex BD version 31 for wood framing introduces two new roof accessory tools for rafter framing: collar tie and strut tools. In addition to these new tools, the wood version of Vertex BD also provides Purlin and Strongback support line framing details. To access the roof accessory tools, navigate to the Modeling ribbon menu, select Floor Panels, and then Framing Accessories. In the browser window, choose Roof Accessories under Accessory Tools. Add a single collar tie or apply multiple collar ties to a designated area. Struts can be added using one of four accessory tools. Add strut to bottom of part to free point. Place a strut under a supported part and angle it to any point below. Add strut to side of part to inline point. This tool adds a strut inline to the side of a part. Add strut to bottom of part to top of another part. Place a strut under a part and angle it to any point on top of another part below. Add strut to side of part to top of part. Add a strut to the side of a part, inline to the top of another part below. To add a single collar tie in the framing model, select a rafter followed by the selection of an adjacent rafter. A collar tie parameters dialog box opens. Click the SEL button next to the material code field to change the collar tie's material. To adjust the distance from the ridge to the center of the collar tie, enter a new value in the collar tie distance field. Click OK to add the collar tie. The ends of the collar tie are trimmed to match the slope of the rafters. The order of rafter selection determines on which side the collar tie is placed. In this example, if the first selected rafter is above the ridge member and the second follows below it, Vertex will position the collar tie on the left side of the rafters. To add another collar tie on the opposite side, reverse the selection order. First select the rafter below the ridge member, then the one above it. Click OK to use the default collar tie parameters. The collar tie is added to the right side of the rafters. If collar ties are needed on both sides, simply add a single collar tie and repeat the process with rafters selected in the reverse order. To add multiple collar ties to an area of rafters, use the Area Collar Ties Accessory tool. Create a crossing window to select rafters on both sides of the ridge. It is acceptable for the ridge to be included in the selection, as Vertex will ignore it. Press the V key to confirm or right-click and select OK. The collar tie parameters window opens. Make any necessary adjustments before clicking OK. Currently, the Area Collar Ties tool does not have an option for double collar ties. To create double collar ties, use the copy command to duplicate existing collar ties to the other side of the rafters. Before demonstrating the strut accessory tools, I will introduce two new support framing details: Purlins and Strongbacks. For this demonstration, I will select a roof plane. These new details can be found in the Plane Structure menu under Framing Fields and the Lines tool. Right-click and select Add Support Line from the Context menu. I will draw a support line spanning the width of the building. In the Framing Detail window, choose the framing detail to apply to the support line, which includes a 2x6 edge and 2x8 edge Strongback detail, along with a selectable Purlin framing detail. I will select the Purlin framing detail, click the Parameters button to choose the Purlin piece, and then select OK to close each window and apply the Purlin. Note that the Purlin is applied below the roof framing, while the support line is based on the top of the roof framing. This results in the purlin being offset from the support line. The purlin can be modified like any other profile in Vertex BD. I will adjust the end of the purlin so it aligns with the inside of the wall framing. To add a strongback, follow a similar process. Select the roof plane. Select the Lines tool from the Framing Field's ribbon menu and right-click to choose Add Support Line. I will add another support line spanning the width of the building. Here I will select the 2x6 edge with 2x4 flat Strongback framing detail in the Framing Detail window. Strongbacks do not require parameter settings. Simply select OK to apply it. The Strongback is now positioned under the roof framing. The edge and flat pieces comprising the Strongback are individual profiles that can be modified. I will adjust the ends of these parts to ensure they butt up against the inside of the wall framing. Strut accessory tools can be found under the Modeling ribbon menu, specifically within the Floor Panels and Framing Accessories section. There are 4 main tools available for adding struts. Let's begin with the Strut, bottom of part to free point tool. This tool allows you to add a support strut beneath the selected part. You can place the bearing end of the strut at any point below. To add struts to your 3D framing model, use the Zoom and Rotate tools to select the desired parts or members. You may need to hide certain objects to achieve an unobstructed view of the model. For example, I will add a strut to support the Strongback. For the first selection, select the 2x6 edge profile of the Strongback. Next, for the strut connection point, pick the bottom edge line of the profile. The bottom end of the strut will be positioned on the wall below. Zoom in and select the surface plane of the top plate of the lower wall. Use the Shift-M Snap hotkey to select the surface. In the roof strut window, I will keep the material code as 2x4. For the rotation, I will change the piece from 0 to 90 degrees. This adjustment changes the orientation of the strut from an edge position to a flat position. Next, use the bottom plane height field to verify that the bearing end of the strut is at the correct height. Make any necessary adjustments. Select OK to insert the strut. This strut will now support the Strongback and bear down onto the top of the wall below. I will add another strut using the Strut tool, side of the part to inline point tool. This tool adds a support strut to the side of a part. The bearing end of the strut is inserted in line with the top support point. In this example, I will add a strut to the side of a rafter, with the bearing end placed on a wall below. First, I will select the top connection piece. Next, I'll choose the side of the rafter and the location point for placing the strut. To do this, I will move the cursor to the side of the rafter and use the Shift-M hotkey to select the side surface plane of the rafter. Then, I will select the top plate of the wall below as the location for the bottom end of the strut, again using the Shift-M keys to choose the top plate surface plane. Since the strut will be placed in line with the top support point, the exact location of the selection point is not important. Vertex only needs to know the plane height. In the roof strut window, I will leave the settings unchanged. The material code is set to 2x4, and the rotation is set to 0 for on-edge orientation. The strut accessory tool has a horizontal offset parameter. Use this parameter to adjust the strut's location from the side of the rafter. I will leave the offset at 0 for now. The bottom plane height is correct. Now select OK to insert the strut. The strut is added to the side of the rafter for support. The strut bears on the wall below while maintaining an inline angle. Another tool for creating struts is designed to connect the bottom of one part to the top of another. This accessory allows the user to place a strut under a supported part, which can bear on top of another part at any angle. In this example, I will add a strut to support the purlin, with the bearing end resting on the beam below. First, select the top connection piece, which is the purlin. Then, choose the connection point on the purlin. For this, I will select the bottom edge line of the purlin. This connects the top of the strut to the bottom face of the purlin. Next, select the bottom connection piece, which will be the ceiling beam below. Choose the connection point on the bottom piece by selecting the surface plane of the top of the ceiling beam. This is the strut bearing point. Position your cursor over the top of the beam and use the Shift-M snap hotkey to select the surface. In the roof strut window for this accessory tool, you will find fields for material code and rotation. I will leave the material code set to 2x4 and the rotation at 0 to achieve an on-edge strut orientation. Select OK to insert the strut. The top of the strut will support the purlin while angling down to rest on the ceiling beam below. The final example of the strut accessory tool is the strut, side of part to top of part tool. This tool adds a support strut to the side of a part. The bearing end of the strut is inserted in line and rests on the top of the support part below. I will add a strut to the side of a rafter, and it will bear on the ceiling beam below. Select the top connection piece, the rafter. Next, choose the side of the rafter and the specific location point where you want to place the strut. Move the cursor to the side of the rafter and use the Shift-M hotkey to select the side surface plane of the rafter. Select the ceiling beam for the bottom connection piece. Select the top of the beam, again using the Shift-M keys to snap to the top surface of the beam. The bearing end of the strut will be aligned with the top of the strut. The exact location of the selection point is not important. Vertex only needs to know the height of the surface or bearing plane. In the roof strut window, leave the settings unchanged. The material code will be 2x4 and the rotation will be set to 0 for on-edge orientation. I will also leave the horizontal offset value at 0. Select OK to add the strut. The strut has now been added to the side of the rafter, bearing on the beam below while maintaining an inline angle. Switch to the 2D view to see the struts in plan view. The inline struts appear straight, while the point selection struts are angled. This is due to the top and bottom ends of the struts not being directly in line. This concludes the roof accessories video. Be sure to watch our other videos to learn more about the various features available in Vertex BD.